Hi, my name is Kelsey Broich. I'm a design technician for UGA Marine Extension and Georgia Sea Grant's Stormwater Program. I also recently graduated with my master's in landscape architecture, and today I will be sharing my findings from my graduate thesis. I'd like to begin by acknowledging my committee members, Dr. John Calabria, Brian Orland, Mark Reese, and Jessica Brown. This research was supported by UGA Marine Extension and Georgia Sea Grant's Research Traineeship program, and also with a grant from Sawtooth Software. So my interests began with a conversation about the improper management of bioretention systems and a desire to understand how people perceive bioretention practices. And so the broader goal was to improve the design, the visual design of bioretention practices in order to have better stewardship and acceptance of them. So this thesis is a landscape perception study that uses a photo-based survey to test how people react to coastal bioretention practices across the seasons. And the overarching question is, how do seasonal change and design features interact to contribute to an eco-visual aesthetic for bioretention practices? So my presentation will begin with an overview of how aesthetics relate to sustainability, and then into the design of the survey, and finally the results and what implications they have for future research or design considerations. So landscape perception is the body of research that tests visual preferences for landscapes. So it began with the preservation of our parks and visual natural resources. So taking a look at beautiful places and resources and deciding which ones we decide to preserve. However, testing preferences for large-scale landscapes such as national parks will differ from testing preferences for smaller landscapes such as green spaces or built environments. And as we all know, these smaller scale landscapes in the built environment are important places where decisions can be made, such as implementing green infrastructure to improve our watersheds. So wetland environments are often misunderstood, and without knowledge of their function and ecological benefits, the layperson may only perceive them as messy or unkept, leading to a lack of appreciation or even removal. The visual appearances have the potential to connect people with wetland environments and support better stewardship and maintenance. In naturalistic planting designs, seasonality is often used as a visual aesthetic. And plant designers choose plants that have visual interest throughout the year, like having flowering plants in the spring or grasses that hold their form in the winter. And so we chose to test preferences for seasonality as the primary aesthetic feature within this study. We selected 5 sites within Georgia's coastal plain, and they represent places that are bioretention systems. They performed well at the time of selection and are located in a public site. We did not have control over the design of the sites. Each site was photographed 5 times throughout the year, and we used an iPad to create consistent photos between visits. So the iPad had an app that you could add the last visit's photo over top with a grid, so you can get the proper alignment. And then we also took additional photos with the DSLR camera to have high quality images. So this is an example of a set of images for a site. In addition to the 5 different times throughout the year, we took 3 photos representing different views of the same site. However, the views were not explicitly similar between sites. So often, photo-based landscape perception surveys will ask for a rating. So please rate this image on a scale of 1 to 10. However, in this study, we decided to use the discrete choice experiment, which is a method that presents respondents with a series of alternatives. So the discrete choice experiment is new to landscape perception research, and it was designed for market research. And so it better represents the decision-making process by choosing between alternatives or trade-offs. So each photo is coded with attributes such as seasons. The respondents are asked to complete 20 random comparisons. The comparisons reveal estimates for which attributes contribute to preference. While 3 attribute categories were used in the design of the survey, we primarily tested for seasonality. These attributes were used in a pilot survey to test their influence over the seasons. So in addition to those comparisons, respondents were also asked demographic questions in a series of statements using the new ecological paradigm scale. So these are a series of statements where the respondents are asked their level of agreement or disagreement. And the total score of those decisions reveals their attitudes towards environmental concerns. So again, we used a pilot to test our methodology. We analyzed the results using hierarchical Bayesian analysis, a method that estimates utilities or how much an attribute contributed to a person's choice. We also used counts, a method that calculates the proportion of a level, such as fall or winter, was chosen based on the number of times it appeared in the survey. And finally, though anecdotal, we compared the most and least preferred photos with the additional factors table. This was used to see if any additional commonalities existed in the photos, such as flowering plants or open water. And within this table, we also noted the average color of the photos using an online website that calculates average color based on pixels. So these are the results from the pilot study. We distributed an online survey to design students at the College of Environment and Design. We received 53 responses and found that seasonality was indeed significant with a p-value less than 0.01. Respondents preferred the growing seasons, spring, summer, and late summer over dormant seasons. The pilot also revealed that site was significant. So one site was chosen more than a particular season, and upon review of the site's photos, it was determined that that site was drastically different from the others and was removed from the next survey. We distributed the next survey using an online commercial panel. We received a total of 985 responses. The results reveal again that seasonality is significant with a p-value less than 0.01, and respondents preferred the growing seasons, spring, summer, and late summer, over dormant seasons, fall and winter. No correlations were found between demographics and seasonal preference. Any p-score suggests that 80% of the respondents lacked environmental concern, but no correlation was found between any p-scores and seasonal preference. Unsurprisingly, the respondents preferred the growing seasons over the dormant seasons, but while seasonality was found to be significant with a large sample, the adjusted R-squared accounted for less than 1% of variance. In addition, no relationships were found between demographics and seasonality to provide any actionable findings toward a specific segment of people. Counts are the proportion that an image was chosen based on the number of times it appeared in the survey. Reveals that spring, summer, and late summer were chosen 50% of the time they occurred, while fall and winter were chosen less than 50% of the time they occurred. The most selected image was taken in late summer and was chosen 64% of the times that it occurred. Anecdotal observations suggest that the characteristics of the vegetation, such as color and height, may impact preference. So according to the average color generator, the most preferred photos are mostly blue and green, while the least preferred photos were gray and brown. And perhaps the respondents are reacting to the overall color of the image. So as you can see in these most preferred photos, they're very lush and green from the summer, while the least preferred are in the dormant season and are very brown. So while the results are not actionable towards any specific segment of people, they do point to new directions in research, such as whether or not similar studies that look at different photos get the same result, or testing vegetation characteristics, especially in winter, or testing relationships between seasonality and behavior. Again, the study's findings may be unsurprising, but it suggests that bioretention practices may be most at risk for mismanagement during dormant seasons when they are least visually appealing. Perhaps landscape designers and extension professionals should consider year-round seasonal interest, like the images here, planting green plants that remain green, or provide winter interest in the visual design of bioretention practices. And further research should explore potential links between intentional winter design and stewardship. Thank you.